So in this video, you're going to learn about scatter plots, outliers, and correlation coefficients, and hopefully this will be a review of scatter plots and outliers from 8th grade. Okay, so here are examples of scatter plots. Scatter plots are a bunch of points on a graph, okay? So there are three types of correlations. Correlations kind of like a relationship between two things. So are they strongly related, or are they not as strongly related? Okay, so to figure out which one is positive, negative, or no correlation. So when I look at A, we see from left to right that it's going down. So this would be called a negative correlation. Okay, and that's a pretty strong negative correlation because those points are very close together and not spread out. Okay, B would be considered no correlation. Because the points are a little bit more spread out, you really can't tell if it's going up or down or anything like that. So then part C is going to be a positive correlation because my points are going up. And we notice that it's not as strong of a correlation as A because the points are a little bit more spread out, but it is a positive correlation because I can tell if those points are going up. Okay? Next thing, I want you guys to try this on your own. Determine whether the scatter plots below show a positive correlation, negative correlation, or no correlation. And then if there is a relationship, describe it. So tell me in words what kind of relationship is happening. So press pause and try them on your own. Alright, so for number 1, I got no correlation. There is no correlation between the number of siblings you have and how much you're going to weigh. Okay? The dots were all over the place. I'm on 2. I got a positive correlation because my points were going up. And so that means I can talk about a relationship between the weight of a backpack and the number of hours. So what I said was the more a backpack weighs, the more homework you will have. So if your backpack weighs 7 pounds, you're assuming that you've got a lot of homework to do because you're carrying home these books and you're carrying home all this stuff. So of course it's not always true, but more likely the heavier your backpack is, the more homework you're going to do that night, okay? Alright, so next thing we're going to move on to what is an outlier. I kind of think of outlier as out there. So it's a data point that is distinctly separate from the rest of the data. So it is not in the data, it's outside of its range. So what the question is, so the two scatter plots below show the same data set. Choose the scatter plot which the outlier is highlighted. So if you can't see, here is the highlighted one, and then here is the highlighted one. So it's basically saying, is the one on the left or the one on the right considered an outlier? And this would be our answer. Okay, so this problem right here contains the point that is an outlier. It contains the point that is outside of your data range, okay? So that's how you determine an outlier from a graph. Okay, so this is on Excel, and you can practice on that in a second. Lastly, is probably the most important thing. It's called a correlation coefficient, and it's represented by the letter R. Okay, so it's a value between -1 and 1. So it does not go to a -2, it does not go to an 8, it only goes between a -1 and a 1. So we'll be dealing with decimals and fractions and so on. So if the correlation is negative, so if your line is going down, you're going to have a negative correlation number. So you're going to have, for example, like R equals -0.2. Okay. If the correlation is positive, that means your line is going to be going up. So if you had like R equals 0.8, your line was positive, so it's going to be going up. So it's almost a little bit like your slope of the line, okay? So let's take a look at what some correlation coefficients look like. So the closer the points are together on a graph, the closer it is to a 1. So for example, these points are really, really close together, okay? So it would be like a 0.9, for example. It's going to be really, really close to a 1. The reason it's negative is because they're going down, okay? For this one right here, they're somewhat close together, but they're not as close as this one, so this would maybe be a 0.8, okay? And then something like this that has no correlation, the closer to 0 is going to mean no correlation. So if it's strongly positive, it'll be a 1, and if it's strongly negative, it will be a -1, and then it's kind of, the closer you get to 0, which is like 0.1, that's the more spread out they are, okay? All right, so let's take a look. These are some IXL practice where you're going to match the correlation coefficient to the graph, okay? So I've got r equals a 1 and r equals a -0.1. So there's two ways to kind of think about this. One, obviously this graph is very far, the points are far away from the line, so that's not going to be a strong correlation. These points are all on the line exactly. So this would be an example of r as a 1. So when r equals a 1 exactly, that means that all the points are going to be located on the line. It was 100% linear, okay? So then that means that this would be r equals -0.1. Okay. Another way you can think about it is if obviously this line number is positive, it's going to be going up, and then obviously this number is negative, so it is slightly going down. Okay. So that's how you match a correlation coefficient with its graph. So let's take a look at another example. All right. So again, I have r equals -1, which is 100% linear but going down, and then I've got r equals 0.8. So this one is going to be r equals -1 because all of the points are on that line and the line is going down. This would be an example of 0.8 because it's not 100% linear, but the points are really close to the line and it is positive. Okay. All right, so why don't you try this one on your own? Take a guess which one is 0.3 and which one is -0.2, and then we'll go over it. All right, so this first one is going to be a 0.3 positive because the line is going up. It's barely going up, but it is. And then over here, again, this is a -0.2 because both of these numbers are really not close to a 1. They're actually closer to a 0, and that's why the lines look more horizontal and more spread apart. Another way you could have looked at it is these points are a little bit closer to the line than this 0.2, so that's why it'd be a 0.3 because that would be closer to a 1. All right, so I want you to try the next two on your own, and then we will go over them. So go ahead and try the next two and press pause. All right, so the first one is a little bit more spread out, which is why I picked the 0.4 number. Again, they're both negative because the dots are both going down. Again, this one was a lot closer to the line, so it'd be closer to a 1 and closer to a -1 because the points are going down. The last one, again, they are both negative, and so this one was more spread out, but again, this is technically closer to the line. Again, if you're going to be really close to a 0, you're going to have a horizontal line like this. So kind of the steeper the slope is, the higher the number, and the more flat the slope is going to be the smaller number. Okay. All right, so now you get to practice on your IXL. So K8 is interpreting a scatter plot, so positive, negative, no correlation. K9 is going to be finding outliers, so find the points that are outside of your data set. And then 10 is going to be matching the correlation coefficient to scatter plots, like how we just did. Okay, thanks for watching.